Now let's continue with our second speaker, Dr. James Sherwood. He is a research fellow at the University of York, and he's also part of the Champions team. In his presentation, he will explore on how to include planetary boundaries as a tool in environmental sustainability assessment. So now, after being introduced, let's see if it's possible to mechanize them into an assessment. He will look at the differences from life cycle assessment and will demonstrate how we can compare different products and determine impact targets. Dr. Sherwood, please.
Thank you. Yes, let me put the screen up. Okay, very good. Yes, thank you for having me. And hopefully I'll carry on from what Angel was saying, and we'll delve deeper into the planetary boundaries. So first of all, I'll just cover what was alluded to earlier in terms of absolute environmental sustainability assessment. And we'll make the initial comparison with LCA. And we'll also look at the actual calculation. Most of what I'll talk to you today will be a sort of step-by-step calculation of how to get from a relative assessment to an absolute environmental assessment. And then ultimately we'll talk about what are the implications of this, how can we use it, does it make sense, does it fit into existing policies. So if we start with a typical midpoint LCA indicator, this is where we measure sort of the physical outputs or inputs into a process or a product. And we have here, if I highlight, so our typical LCA indicator will have an environmental impact divided by a functional unit. And we want to minimize the environmental impact. We want to maximize the efficiency, the benefit, the service of the product. So a quite common example would be car emissions. And here we've got the amount of CO2 released per kilometer. So this is quite a small number, 0.2 grams of CO2 per kilometer driven. You might think that's not very much, that might be acceptable. But also we know there's a lot of issues around climate change. And so maybe that's not acceptable, maybe that's way too high. But we can't really tell, other than to say we can compare that to a different car. We compare the emissions of one car to a bus or a bicycle. But again, it's still quite relative. We don't know if it's actually sustainable or not. What we can't also do with midpoint LCA indicators is compare this type of emissions, so here it's greenhouse gas emissions, to different types of emissions from different types of products. So I can't compare the carbon emissions of a car to the water use of using a washing machine. Doesn't make any sense. You might think there's no sense in comparing those two things, but the idea is to get a common standardized basis across all these indicators that we use commonly in LCA. So what has happened in the last few years is to develop something called absolute sustainability assessments. So this is one example that I've worked on, and I'll use this in my case study. We have the same variables as an LCA, so the impact and the function of the product. What we're doing is we're just normalizing these values so they become sort of balanced against a reference. So if we look at this ratio here, the environmental impact divided by the permissible impact that product should have, which would be a share of the planetary boundary. This is our typical absolute environmental sustainability assessment. It's usually done on a large scale, so global activities or maybe regional activities. And there's a few papers now emerging in this area in the academic literature, but it's still quite new. We're talking about 5 years old at this point. What I've worked on is thinking more about individual products. I think it's more relatable to the work that I do. Day to day, I'm a chemist here at the University of York. So to scale down from regions and the global scale to individual products, we have the function of the product from before, but also now we are dividing that by demand for whatever function that product provides. So it could be transport, it could be amount of laundry that needs to be done, whatever the product is performing. So now we've gone from thinking about things on a global scale to individual products. And I will indeed use the example of water use for washing machine. The reason I chose this study is not really related to my usual work. It's because of work by Morten Ryberg. So there are some references at the end. The very first example of an absolute sustainability assessment was on the water use and other impacts of washing machines in Europe. So a wider, broader sort of regional scale assessment. So what I'll do today, I'll talk about defining a scope for a single product, so one washing machine. And then we talk about the share of the planetary boundary. How do we go from something that describes the maximum impact we should have on a global scale to one of a single washing machine? And then we'll talk about the actual magnitude of the impacts, so particularly water, and then we'd have a bit more of a discussion on applications and limitations of this calculation. So the scope does not just involve the turning on the washing machine, putting the clothes in. We're also going to think about making the washing machine and the detergent, and also the supply of electricity and water. The case study today will be based on the UK in 2016. This is just because there's a good data set which I've used, and that will come apparent later. The function of the washing machine is to wash clothes. We're going to use a functional unit in LCA speak of one wash cycle. So everything's scaled down to one wash cycle. Technically, it should be the amount of clothes washed. If you put more clothes in the washing machine, you get better function for the same environmental impact, which would be the amount of water, say, that is used in the wash. So although we're going to say wash cycles, think of it as a standard wash cycle, about 7 kilograms. And if we're talking in wash cycles, then demand is annual wash cycles, so UK wash cycles per year. So here are the planetary boundaries. What we're going to do in the next couple of slides is work from global scale down to very niche, which is UK laundry. So the green areas are sort of maximum limit of sustainable impacts before we start irreparably damaging the earth. So we're not going to worry about that we've exceeded these in terms of actual impacts. We're going to say here's our target, so the green boundary here. What I'm going to do first is say that we're going to ring fence agriculture, because agriculture uses a lot of land, water, implications of fertilizer use. And so we want to protect food production. And so what we have here is the relative magnitude of the planetary boundaries, at least 5 here, which is the most applicable to agriculture. And the green bars is what we're going to reserve just for agriculture. So you can see that most of the land use, we're going to say, we're going to use most of the land for making food. That's important. Same for climate change, greenhouse gas emissions, water use, and almost all the impacts associated with nitrogen and phosphorus for fertilizer. We're going to say that's for agriculture. So we've already taken out a big chunk of the full global planetary boundary, and now we're looking at non-agricultural impacts, which we've covered in the orange areas here. For water specifically, it's about half and half. So what we're saying now is of the total planetary boundary for the global impacts that we can do. So this is withdrawing water from rivers and lakes. Of the 4,000 trillion litres a year, which we can sustainably remove from the natural environment for our own purposes, about half will be for agriculture, about half will be for non-agricultural purposes. So now if we want to get into the UK scale, or any country for that matter, we need a way of scaling down from global to regional scale. And the most obvious way to do that is to use population, relative population size. This is a nice map from our world in data. Each country is now proportionally sized according to its population. So India and China are very big because they have large populations. You see Russia here and Canada, very large countries, but with a low population density. So now they're smaller. This just gives us a nice way to represent this information of population. For the UK, I'm currently in the UK, and we represent about 1% of the global population. So our reserved water use that we can sustainably use is now down to 14 trillion litres a year for the United Kingdom, non-agricultural purposes. Later on, I'll bring in some other countries as a comparison. It's Turkey, Japan, and Australia, and these are their relative sizes here. So now it gets a bit trickier because we have an allocation of the impacts that we can sustainably incur for regions such as the UK. We need to now divide these according to different sectors of the economy. And the obvious way to do this is via economic size of different sectors in the economy. It's helpful to use money because money is a number, you can quantify it, but obviously not all sectors need to use a lot of water or emit a lot of CO2 and all the other impacts. So it's a bit imbalanced. And you can see things that generate a lot of money are selling houses and cars and the financial sector. They don't need a lot of water. So what I've tried to do is try to rebalance this a little bit. It's not perfect, and this could be an area of debate later on, is that we're going to reserve some of this allocation for unpaid household services, because these also incur impact. So if I complete my pie chart here, what we've done in the UK is via the UK Stats Office, they valued the cost of unpaid services. So we can now use that imaginary money, if you like, to contribute to the total economy. So, for example, transport, this refers to driving yourself to work or to the shops. Imagine you were paid like you were a taxi driver, just to drive yourself to work. That would be a very large part of the UK economy. Same for childcare. Imagine that you got paid to look after your children, which sounds very nice. Unfortunately, there are no plans to do this in real life. This is just a theoretical exercise. But again, that would be a massive part of the economy. Imagine you got paid to clean your own house as if you were a cleaner, or paid to cook your own meals like a chef. And indeed, if you were paid to wash your own clothes. So if we were paid to wash our own clothes in the UK, that would account for 3% of the UK economy, just paying people to wash their clothes. And if we take that 3% of our remaining part of the planetary boundary, we get to a share of the planetary boundary just for UK laundry of over 500 billion litres a year of fresh water withdrawal. So it sounds like quite a big number. But now we'll work out if that's actually applicable or not, and if it's enough. So environmental impacts. This is back to sort of your standard LCA inventory stuff, where you're trying to work out, the magnitude of the impacts. Obviously, most of the water use of washing clothes is actually in the wash cycle itself. Depending on the washing machine, you can have between 33 to 72 litres of water. They're sort of we're in the norms of what you'll find. You will find washing machines that go beyond that scale, but they're the numbers we use today. Also in the UK, this is based on London, we have very leaky pipes, old Victorian infrastructure, and the amount of water that leaks from where it's been withdrawn to the point of being used to wash your clothes is proportional to the total amount of water used in the washing machine. So this is also significant. And then there are some other water use associated with making washing machines and electricity and making the detergent, but these are quite minimal. So in total, we're looking at for a washing machine that's used 33 litres of water in the wash cycle, another 10 litres of water use is associated with that process. And this can get up to over 90 litres for water inefficient models of washing machines. Right, so now we can actually look at applying these numbers to the actual calculation for absolute sustainability. So these are the values here. We have one ratio here divided by another ratio here. And for our water efficient washing machine, we have a sustainable water use. It comes out of 54%. If we get to 100%, which would equate to 80 litres of water, that's the maximum. This is all based on our share of the planetary boundary for UK laundry, then further downscaled by the right-hand side of the equation to a single washing machine, and that gives us 80 litres. So our inefficient washing machine has a value here of 116%, so that's unsustainable. So we have a target, and we can see that generally washing machine at home is probably going to use a sustainable amount of water according to this method. There are other ways of making this calculation, of course. Now, what I found quite interesting was the comparison between countries. So here are 4 regions, and we're looking at Japan, Turkey, Australia, and the UK. These numbers are their share of the planetary boundary just for their region's laundry water needs. So again, here's the UK value we saw earlier. The other countries are performed in the same way. The actual freshwater use varies according to the washing machine, but here we're going to use the standard water efficient model, 33 litres, and then added to that we have the water leaks, which are the sort of the lighter brown colour here. Australia and Japan have less leaky pipes than in the UK, so their total magnitude of water use is less. In Turkey, they have more leaky water pipes, and also they have a lot of hydroelectric power, which is associated with freshwater withdrawals, and so they actually have quite a large water use impact. The absolute magnitude of the water use is quite high in Turkey compared to other countries on this graph here. Demand is also another important variable. So in these rectangles here, basically the area represents the demand. So on one axis we have washes per household, and then we have the total number of households in that area. So compared to the UK, Australia use about as they're using the washing machine about as often per household as in the UK. In Turkey, a little less. In Japan, about twice as much. So in Japan, they're using a washing machine at home about 10 times a week. So I can't really explain why that is, but this is from a survey done in the scientific literature. And then that's multiplied by the households. If we then use this to fill in the absolute sustainability equation, then we have the UK at 34%, as we saw before, for the water efficient model. Turkey is a little bit less, which is somewhat surprising because of its actual magnitude of water use is quite high per wash cycle. But that's because there's lower demand. So that's essentially brought it down lower. There's also more people per household in Turkey on average, which also helps. This is based on households, not number of people. In Australia, the number's even lower. So we're still in the sustainable region, but it's more sustainable, if you like. And that's despite having it has slightly less water use per wash cycle, but it also helps that, again, they have more people per household on average in Australia compared to the UK. What's maybe quite surprising as well is that in Japan, we have a sustainable amount of water use. The actual water use is very low, but the demand is high. But these things have sort of balanced each other out, and it's still within the sustainable range. So in these 4 territories, water use is sustainable for washing clothes using a washing machine, at least by this method. What's not sustainable is the climate change impact of using the washing machine. So this is, again, this is for the UK. We have the 34% for the freshwater use, but the climate change impact is over 1,000%. So we need to reduce this by a factor of 10 to get anywhere near sustainable. And this is because of the way that electricity is produced. So these are carbon emissions due to fossil fuels being used to produce electricity in the UK. So we're in the very slow progress of trying to correct this, but we're sort of going in the right direction. But it's obviously much more of an issue than the water use. But I focus on water use because it's easier to see in this example because it's about washing clothes, so water is the sort of integral part. Land use is also unsustainable, which is surprising, you might think, because you don't need much land to operate a washing machine and wash your clothes. But actually what happens is the detergent is made from surfactants. Surfactants are made from natural oils such as palm oil. So the palm oil that's needed to make detergent is not very much, but because, if you remember way back, we gave most of the land that's available to use to agriculture, we have very little room to use land for things that aren't food, which is a bit of a problem. I work on bio-based products, so I advocate for making things from plants, chemicals, etc. The way that we get around this is to use food waste, agricultural residues, things like this, so we can sort of double up on the impacts. So there are different ways of doing the calculation. Angel briefly mentioned about using weightings to get more information about how we do impact assessments. So I have 2 examples here. The top one is about an economic weighting. So rather than sharing out planetary boundaries to regions based on population, we could also factor in the wealth of that region. So countries which are richer per person probably have enough money to then sort of target stricter impact guidelines. So the UK can invest more into trying to meet a stricter threshold for how much pollution they should cause, be it water use, CO2 emissions, etc. This graph here is a bit complicated, but it's basically the weighting system. Basically, we're taking planetary boundary space from the rich and giving it to the poor. That's essentially what's happening here. Under this methodology, all the countries I've covered are losing the share of the planetary boundary, and the UK is losing quite a lot, down to 6% of what it was, which means the actual result of the absolute sustainability assessment is very high numbers, way above sustainable limit of 100%. And this is an interesting endeavor, but it's very hard then to say, okay, we're going to reduce the amount of water from a washing machine by a factor of 9 in the UK, but only a factor of 2 in Turkey, and in some countries, no, they will be sustainable using much higher quantities of water. So it brings in a bit of imbalance, but it's useful to do multiple versions of the calculation just to get an idea of sort of the ranges of numbers we're looking at. The lower example uses the aware system of water availability. So this is a multiplication factor that depends on the water availability of a region. So Japan and UK are quite wet, whereas Turkey and Australia are much drier climates. And so we use this multiplication factor to reduce, say in Japan, the number is reduced because they have more than average water that they can withdraw upon. Whereas in Turkey and Australia, then the numbers get super high. And it's not, I would say, fair that we say, okay, in Turkey and Australia, reduce your water use by a factor of 10. I don't think that really works, but it's useful to have it there so you're aware of water availability. Freshwater use is one of the planetary boundaries which is actually quite localized. Obviously, some places are in drought, some places experience floods. So we need to think more regionally. And this is just one way to do that. So in the last minute or two, I'll just cover policies. I'm not an expert in LCA policy, but I from what I understand of things like the PEF, the product environmental footprint, is that it's still very much in the LCA mold, using benchmarks, and we're using categories to rank compound products to other products. So we haven't rid ourselves of these comparisons. In terms of targets, now you can imagine, maybe in the future that we start to set targets on products, especially. So product manufacturers would have to make washing machines for the UK market using no more than 80 litres of water per wash. This is a good aspiration, but it's sort of strange then to think that in Japan it will be much stricter because of their high demand, and in Turkey, it will be different again. So, does that really work? Maybe that's a debate we might want to start in the Q&A. There are limitations to this methodology. It's quite new. You think of LCA, it's been around for a long time now, and we're still refining how LCA works. This is only 5 years old, and so we've got lots of uncertainties and issues to resolve. One is that there's a big margin of error with the planetary boundaries. We're not really sure what the values are. They come with big error margins. Despite calling it absolute sustainability assessment, it's actually subjective. I've made choices in this talk about how we distribute the planetary boundaries and the use of characterization factors. So that's an area, again, where we're not actually absolute sustainable. We're still on that pathway. Something else that Angel raised in his talk was about applying this sort of viewpoint, early stage, discovery stage, R&D. At the moment, it's quite difficult still because we're thinking of commercial products that we can assess demand for, and we need economic sectors to downscale the planetary boundaries. So this is, again, a work in progress. We don't have much in terms of targets for research and development. We have the possibility of introducing targets now for products, but we could also make targets based on demand. We could say that in Japan, you wash your clothes too many times. I don't think people would like this very much. So this is a sort of a word of warning about how we use this in the future. I don't want this to be used to dictate on people how you should behave in order to save the planet. That might be the excuse that's used. I think that the emphasis should be more on product manufacturers than it is than people. And so finally, last slide. I'm a couple of minutes over, so I'll be quick. Right at the beginning, I talked about car emissions. We don't know if it's sustainable or not, and we can't compare it to other types of impacts from other types of products. But now, basically, we can, because we remove the units from our assessment. You might still think it's a bit strange to compare these, but our reference point, we have a benchmark, which is the 100% level, which is the sustainable maximum. So as you might imagine, petrol car emissions are too high. And as I've explained to you, water use of washing machines is okay, with some caveats, depending on how you allocate the planetary boundaries. And that's it for me, thanks. So thank you very much for listening.